Hello. So today we're going to be explaining arithmetic sequences and series. So before we start, a little refresher of sequences and series will be helpful. So basically, a sequence is a set of numbers that just proceed after each other. So such as U1, comma, U2, comma, U3, dot, 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 UN. The sequences are distinguished by the use of the comma to separate the different terms. This is different than a series of numbers, which is the sum of a sequence. So, for example, U1 plus U2 plus U3 plus dot 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 UN. So this is the difference between sequences and series. So in order to quickly write a series, we use sigma notation, which is, the notation is as follows. N is like written right above large sigma, and then underneath you put I equals 1, and U I. So this is saying that the sum of all the terms UI from I equals 1 to I equals N. So applying this to arithmetic sequences and arithmetic series, we know that the arithmetic sequence has an equation of U sub n equals U sub 1 plus the quantity n minus 1 times d. Now, if we were to pick this apart, we know that U sub n is the desired term you were trying to find. U sub 1 is, of course, the first term. N plus 1 is the which number term it is. So n is the number term, and d is the common difference. So the common difference in a certain sequence, say for example 84 comma 81 78 comma dot 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 12. So the common difference for this is 6. So the common difference is negative 3. So 84 minus 3 gives you 81, minus 3 gives you 78, so on we get to 12. This is just an example to find different terms and how many terms are in this sequence. So the U, what we would do for this particular example, UN would equal 84 plus n minus 1 times negative 3. We get UN equals negative 3n plus 87, and this would go into 12 equals negative 3n plus 87, because 12 is the end of the term. So 3n equals 75, and the number of terms are 25, so there are 25 terms in the sequence. So from this equation, we know that this equation is helping us to find the number of terms. Now we can manipulate this in order to find, say, the first term or the common difference, etc. Now, as that was sequences. Now, as far as arithmetic series goes, there's a slightly different equation. So since the arithmetic series is the sum of the sequence, this is denoted as S sub n equals n divided by 2 times the quantity u sub 1 plus u sub n. Or S sub n equals n divided by 2 times the quantity 2 u sub 1 plus the quantity n minus 1 times d. Now, if we look carefully, this looks a whole lot like u sub n equals u sub 1 plus the quantity n minus 1 times d, which is the arithmetic sequence equation. So this is just using different manipulations. It's just manipulating the equation in order to find the sum of this sequence. So again, we have d as our common difference, and u sub 1 is the first term, and then whatever number term you're talking about, and S sub n is denoted as the sum. So Tommy will go ahead and give us an example of this.
Sure. So I'm just gonna make this easy and have just my note sheet. All right. So in terms of arithmetic series, so we were already given the formula. So for this specific example, we're gonna find the sum of the first 15 terms of, and they'll give us the first 3 terms. So 29 plus 21 plus 13 plus, and it goes all the way up until into infinity, but it gives us we're gonna find the first 15 terms. So we're gonna use this first example or first formula to find the first 15 terms. So we're just gonna plug in. It's as easy as that. So for n, so that's just the number of terms that we're finding. So n is just gonna be 15, so it's gonna be 15 over 2. And then it's gonna be u sub 1 is just the first term in the series, so 29. And then plus u sub n, which is just u sub how many terms, so it's u sub 15. So from there, we need to find the 15th term, but as we find out, we can't really use this formula because u15, we don't know what it is. So we're gonna have to use a different formula to find what this u15 is. So we're gonna use this next formula. So really, whenever you're doing these problems, you're gonna need to use either the first one if you know that 15th term, or whatever term it is in the problem, or this other formula if you don't know what that term is. So as we saw, we started it and we don't know this 15th term, so we're just gonna go to the second formula. So again, it's 15 over 2, and then 2 u sub 1, so it's just 2 times 29 because 29 is the first term, plus, and then it's going to be 15 minus 1, which is because it's n minus 1, and then times the difference, which is we see that they subtract 8 each time. So it's times negative 8 because that's the difference. So really we just plug in and solve for this 15th term, and then we find that the sum of the first 15 terms is negative 405. And it's always good to kind of think about the problem and make sure it makes sense. And it does, because as we see each time they subtract 8. So it's going to keep going down into the negatives and, adding to that into the negative side of the problem, and it will go to negative 405. So that makes sense. So we're good. All right. So thank you.